So yes, so when we change the degree to 2 again, when we change the degree to 2, okay, let's change it to 5. Let's change it to 5 and see what's up here. Almost perfect. It's getting, so when we keep on tweaking the degree like this, you see 0.7, which is not what we want. We want 0.9, we want 0.95. This is 0.7. the r squared is 0.7, which is what we don't want. When we change it to 1, look at what the r squared was, the degree to 1, 0.5. Very, 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 very poor, very poor. Well, immediately we change it to 10. From 10 up, I think it started giving us perfect results. Yeah, it started getting close to perfection. So now I'm going to show you where I applied it to give me new data, for new data input. I'm going to show you the code. This is the code. So take note of this code, pause it, and this is a new data set. This NR is a new data set. Yeah, this NR is a new data set. So I'm going to be showing you what's up here. 2422. Let's copy out this, because I've told you before, machine learning treats the output like it doesn't exist after training, like it doesn't exist. So when we put a new data input, it's going to predict us an output as if it doesn't exist. So it may be something different from the original one. So this is where I'll be entering a new data input. I'm taking my degree to 14. So let me take my degree to 10 first. Taking my degree to 10. Polynomial features. This is the part where we will prompt for the new data. We prompt for the new data up to this point. We are going to prompt for the new data. Yeah, and all these ones we are going to print it. So let us run this code. Remember, my degree is 10. So I'm going to put the new data point 1.0423 and 1781. And let's see what the output is. You can see it's very, very close to what we predicted with the actual data. So this is 1.2425, which is very close to 1.2422. So let us further tweak our, let us copy this one now. Let us further tweak our degree. Let us change the degree. Let's change the degree to, let's say, 13. And run this. So we are going to put in the new data. Can you see? It's almost perfect. 1.3776. 1.3779. So it's just 3. You can see 1.3779. So it's just 3 points different. So you can see that it's almost perfect. After all, this is the r squared, 0.9. That is 97%. So thank you very much for learning polynomial regression. This is all about polynomial regression. It's just an upgrade of linear regression. Copy this code. Make sure you have all this code. Thank you. Next, we'll be discussing about SVR. That's support vector regression.